My name is Bruce Stillman. I'm a biologist and biochemist who works on genetic inheritance, and I'm also president of Cold Spring Harbor Laboratory in New York. Welcome to my exp. One of the fascinating things about science, and the reason I think why I pursued a career in science rather than a career in medicine, which I had the choice of doing, was because I really enjoyed the scientific process. When I was an undergraduate at university, I worked in laboratories and I was exposed to the daily life of a scientist. That is, that you can go in and do some experiments, design experiments, and do some experiments and get the results and sit down and look at the results and start to think about the implications of those results. And you're the first person to see those results. This generates lots and lots of ideas in your head, and you have to then come up with different ways of testing those ideas. And a critical component of being a great scientist is actually to choose which ideas to choose and which ones not to pursue, because you can go down the wrong path very easily if you're not smart enough to really kind of figure out what the data is telling you and where to go. One of my former colleagues and Nobel laureate, Barbara McClintock, who I used to have a lab next to her for many years, for about 12 years, she used to say, look at the material, or in her case, she worked on corn. She used to look at under the microscope, but look at the plant cells and the chromosomes she was studying and let them talk to her. She was kind of almost mystic in that sense. And scientists are like this. They have a passion, a true willingness to go and try and understand what has not been understood before. And that's the thing that I really like about science. It is not only breaking new ground, but this kind of daily challenging new ideas and looking at new data that is constantly changing. The questions that I asked when I was a graduate student or a PhD student, or then later on as a scientist with my own laboratory, the questions I asked many years ago are completely different in a small way than the questions I asked then. In the big picture, we're trying to solve a particular problem in biology, that is genetic inheritance, but the details and the experimental system that you're using change all of the time. And of course, the other wonderful thing about science is that you bring in colleagues into your laboratory or have colleagues in your institution that are all very different and come from an extraordinary vast array of backgrounds. The scientific process is coming up with ideas, testing those ideas with experiments, at least in experimental science, looking at the data and trying to interpret that data and come up with hypotheses about how things might be working. And that's what's really great about science. However, one can devise ideas and not have the technology to be able to address those ideas and go for many months or sometimes years without really making a lot of progress. The essence of being a good scientist is to know when to drop that idea and move in a different path. And so you can spend quite a long time having experiments that don't work. But if you look at the experimental process that you're doing, one can then devise a way around that can actually lead to insights and actually major discoveries. And so the art of being a good scientist is not to just stick to one recipe like, a chef would do in a restaurant, but to be an innovative chef, to kind of experiment with different recipes and then eventually come to one that will work spectacularly well and give you new data in which to get insight. It is a process that can be frustrating, but it is also a process that is very informative if you know how to do it properly. And I think that's really one of the exciting things about science. It can be frustrating, particularly for students who come in and they think, oh, I can just do this, this, and this, and this and get a thesis. But if that was the way science was done, we would know everything and you wouldn't be doing research. You would just be churning out the same results that someone else has done before, which is really like the recipe for a cookbook. So I think the developments in science really take someone to have a passion, to have the tenacity to keep on with the problem, but also have the sense to move in a different path, choose a different experimental organism, or choose a different experimental technique to attack the problem, because you don't want to get bogged down trying to do the same thing over and over again and really get nowhere after a long period of time. The success in science is to make new discoveries, to appreciate the wonderful things about nature, and to understand and then be able to reconstruct the process.